Hello everyone, how are you all? My name is Shubhendu Mani Tripathi and I have did my MSc from IIT Roorkee, and today I am going to teach you all a very basic concept of inorganic chemistry. The concept which I am talking about is hybridization. Okay friends, so let's begin. What is hybridization? So let's first considering the hybridization, we should first begin that what is the orbitals. So over here if I am writing S, then it is an orbital. You all know that it is S orbital and its shape is spherical. And then if we are writing P, then it is a P orbital and its shape is dumbbell shape. P is a subshell basically, and it is having three orbitals, and they are Px and then Py and then what, Pz. So these all are what, these all are pure orbitals. This is S orbital, this is P orbital. Similarly D orbital and F orbital also comes. So this is S orbital and this is P orbital. Let's consider a situation if this S and this and any one of these three P orbitals are mixing. So if that situation occurs, then the hybrid orbital will be formed, and it will be having one S and it will be having a 50% S character and a 50% P character, because any one of these P orbital is mixing with this S orbital. So it is having what? It is having a 50% of S and 50% of P character. So basically this one will be what? This one will be a hybrid orbital. Okay, it is different from the sp orbital. It is different from the s and p orbital in the sense that this hybrid orbital will be different in energy, different in shape and everything. Similarly, if we consider that s is mixing with two of any two of these three p orbitals, so we will be having one s and then we will be having two of these p orbitals, and over here what, 33% will be formed with the s character and the remaining will be what, around 66% will be of P character. So this is a characteristic of hybridization. They are not the pure orbitals, rather they are mixture of the atomic orbitals. They display some character of S, they display also some character of P, they display some also character of D, depending upon which orbital has formed to mix with them. Okay. So let's come to another point. What is the shape of the hybrid orbital? It will be completely different from the atomic orbital. As you all know, S orbital is spherical, P orbital is what, dumbbell shape, and then d orbital is having these shapes, means double dumbbell kind of thing. But if I am writing about the hybrid orbital, then according to scientific observations and according to the hypothesis, a hybrid orbital is having a simple shape. It is formed of two lobes, and over here and over there one lobe will be a larger lobe and another lobe will be a smaller lobe. So this one is, as you all know, as you all are, it is quite obvious, it is a smaller lobe and this one is a larger lobe. This one is a larger lobe, and it has been hypothesized that the bonding is formed from the larger lobe. So larger lobe is only responsible for bonding. So bonding occurs from this side, that is from the larger lobe side. Okay. In hybridization, what happens is that orbitals mixes and not the electrons. So basically s orbital and p orbital, if they are mixing, they are forming the sp orbitals. So in sp orbital, if there are two electrons, so it is not different from the electrons with the s and electrons of the p. So basically in hybridization the orbitals mixes, it is not the mixing of electrons. So I am trying to say is that a vacant orbital, a fulfilled orbital and an empty orbital all can mix. Say for example here, over here s is having two electrons. Let's say this condition is over here. Okay, so sp2, or let's say over here also there is only one electrons. So these three orbitals are having what, these three orbitals are having electrons, but they all can mix. It is just an example. Another example could be shown like this. Let's say this is having fully filled s orbital, and over here fully filled p orbital, and then vacant something. They all can mix together. Okay, and they can form sp3. Why? Because there is one orbital from s side and there is p3 orbital from p side. So overall what we can say, that if I am writing over here hybrid orbital, if I am writing over here hybrid orbital, and if I am writing over here hybridization. Okay, so hybrid orbital corresponds to the hybridization. They all will be written in some superscripts. So if the hybrid orbital, it will start from 2. So if I am writing over here 2, it is the hybrid orbital. So the hybrid orbital is what? It will be coming from, or it will always start from the s orbital. So for 2 we need one s and just one p. If hybrid orbital is 3, then we need one s and 2 more p. So it will become sp2. If hybrid orbital is 4, then we need one s and 3 more p. Similarly for 5, as there are only 3 orbitals in p subshell, so we need one s, 3 more p, and then one d. Okay. For 6, we need one s, 3 more p, and then 2 more d. Similarly for 7, there will be sp3d3. So this is the hybridization for this hybrid orbital. Okay. Let's see another thing. Number of hybrid orbital is what? Number of hybrid orbital is equals to, according to NCERT, is equals to the number of sigma bond plus number of lone pair. So let's come over here, sigma bond. As you all know, sigma bond is what? Sigma bond that is always formed. There are basically a very few exceptions like C2 molecule, but sigma bond is always formed. Okay, so sigma bond is always formed, leaving just one exception. And the second point is that it will always be 1 in number. So always 1 in number. Why I am saying this? Say for example, if I am trying to write about carbon-carbon bond. So in ethane, there is a single carbon-carbon bond, and yet over here there is one sigma bond. For ethene, there is a carbon-carbon double bond, and there will be one sigma bond and another one will be pi bond. Similarly in ethine or acetylene, there will be one sigma bond and the other two, they will be pi bond. Okay, so sigma bond is always formed and it is always 1 in number. Okay, so what I have written over here, the number of hybrid orbitals is equals to the number of sigma bond plus number of lone pair. So if I am writing over here 3 examples, say for example if I am writing CH4, so it is CH4, and then over here if I am writing NS3, and then if I am writing another molecule, say water. So carbon is having 4 valence electron and they all are 4 are occupied by hydrogen, so there are no lone pairs. For nitrogen, it is having 5 valence electron, out of which 3 are taken by hydrogen, so 5 minus 3, 2 electrons are left over with nitrogen. For hydrogen, there are 6 electrons and 2 are taken by hydrogen, so 6 minus 2, that is 4 electrons are left away with oxygen. Okay, so over here if I am writing, then sigma bond and then lone pair. So sigma bond over here are 4, and as you can see the lone pair are 0. Over here sigma bond is what? 3, and the lone pair, that is 1. And over here there are 2 sigma bonds and the lone pair is again what? 2. Okay, so what we have written above, that the number of hybrid orbital is equals to number of sigma bond plus number of lone pair. So we can say that we have to sum them. So if I am summing them all, what we are getting? We are getting hybrid orbital. 4 plus 0, that is 4. 3 plus 1, that is again 4. 2 plus 2, that is again 4. And over here we can write it as hybridization. Okay. So the hybridization will be what? All of them are 4. Then you know there is one s requirement and the rest will be fulfilled by p, as because there are p orbital, p subshell is having 3 orbitals, so all of them is having sp3 hybridization. Okay, there is a very small trick to find out the number of hybrid orbitals, and it can help you in very complex molecules also. So basically number of hybrid orbital, that is equals to half of the number of valence shell electrons, number of valence electron plus number of monovalent atoms plus number of monovalent atoms plus charge on an ion minus charge on cation. Okay, so let's try it within. So let's try it for any molecule. Say for example XgO2F2. You all know that xenon is a noble gas. So how many electrons would it be having? It will be having 8 of the valence electrons, 1 by 2 into 8. And then monovalent atoms. What are the monovalent atoms? A monovalent atom is that which is forming only one covalent bond. Okay, so monovalent atom, they could be halogens and hydrogen. So how many hydrogen it is having? 2 halogens. So 8 plus 2, that is 10. So 10 by 2, and that is 5. So for 5 we need what? We need 1 S, we need 3 more P, and then we need 1 more D. Okay. Similarly, let's find out for another example. Let's say we are finding for SO4 2 minus ion. So sulfur, it is having what? Sulfur is having 6 valence electron. So 6 valent electron. Oxygen is not monovalent because monovalent atoms are what? Monovalent atoms are halogens and then hydrogen. So it is having just 6 electron and then plus charge on an ion. So 6 plus 2, that is 8, and then 8 by 2, that is what? That is 4. If I am coming on to the table over here which I have prepared for you all, then what we can say is that for 4 the hybridization is sp3 again. Okay. So the hybridization will be what? The hybridization will be sp3. Similarly, if I am writing over here any of the cation, say for example NH4 plus. So nitrogen is having what? Nitrogen is having 5 electrons. Then hydrogen is a monovalent atoms. They are 4 in number. So 5 plus 4, and then there is a plus charge. So 5 plus 4 minus 1. So 5 plus 4, that is 9. 9 minus 1, 8, and then 8 by 2 comes out to be 4, and then 4, that means what? That means sp3. Okay friends, so I hope that you all have got my point. Okay, thank you very much.